My name is Steve. Welcome to my shop. Before I talk about the project I'm going to be working on today, I'd like to thank all of my new subscribers. This is the one thing that will keep me posting new videos is additional subscribers and the likes and the comments. I really appreciate it. Project I'm working on today is a transport wheel for a stand-up string bass. My nephew plays the bass. He's going to be starting school at Juilliard this fall, and this wheel mounts on the bottom of the bass, and there's an axle that goes up into the bottom of the bass where there's an adjustable peg to adjust the height of it. And for transporting the bass, this unit goes in it so that they can roll it down the street or across the stage or whatever. And what has happened is that the stud that mounts this axle to the wheel broke off. So what I'm going to talk about a little bit today is the failure, the analysis of the failure, and how I'm going to design it to prevent this kind of a failure in the future. The way the piece is made, it's got this pivot pin, I'm going to call it a pivot pin, which has a shoulder, small shoulder, and then it had this threaded piece, and it was severely undercut for threading, and it started to crack right across here. And what happened was, if you look at the cross section of it, it started to crack here and it migrated up, you can actually see, and then it started to migrate around the outside, and then the fretting, it actually started to polish the edges here, and you can see on the failure, I'll try to get a close-up picture of it, it finally ended up with one piece of solid material in the center, and that got to the point that it hit a bump or something, and then it sheared that right off. So what I'm going to do, enlarge the section here. This is the shoulder. It's exaggerated some, but what I'm going to do is I'm going to radius that, and then I'm going to thread it for 3/8 16. It was originally 8 millimeter. And so when they undercut it for the thread relief here, it went down quite small, and it had a very sharp corner here. So I'm going to radius this and make it 3/8. And then what I'm going to have to do for the bracket, where it goes through the bracket, and the bracket gets threaded, and I'm going to chamfer the edges of the bracket to countersink that so that the radius fits up in here and it will still be flush against the bracket. Then I'm going to put a nylon locking nut on it to prevent it from turning. For the material, what I used, I took and got a 1/2 inch grade 8 bolt, and I cut the threads and the head off of it. First thing I'm going to do is face it off and center drill it. running the lathe at about 1,000 RPM. The carbide insert that I'm using is a Mitsubishi on a Char's tool holder. The length of the turn section is just a little bit under 3 inches. So I'm going to mark it. The actual dimension is 2.9, so I'm going to take and mark it off with my caliper and then put a witness mark on it with the full bit. Turning it down to 0.385, the dimensions on the existing piece are all over the place. So the average is about 385, so that's what I'm going to go with. Missed the finished pass with the video, but it turned out right on the money. And now I'm just going to go square off the shoulder. Still pretty warm, and I'm about 1,000th undersized, so I should be just fine. By the time it cools down, it'll probably be about 2 under, which is exactly where I wanted to be. Finish turned out beautiful. Now, the next dimension that I need to concern myself with is the width of this shoulder, and that measures about 190 thousandths. Make a mark. Take and mark my tool bit with the tool bit. There we go. Now I'll be turning this to 375 for my 3/8 thread. I'll stop back when I'm ready for the finished pass. For my finished pass, I'm going to use a high-speed steel bit that I sharpened with a small radius on it to go up against that shoulder. Finish isn't the greatest in the world, but oops. Size is right on, so I'm going to cut it to length and chamfer it to get it ready for threading. Just taking a very light cut just to improve the finish a little bit. Probably only about 1,000. I want it a little bit undersized for the threading anyway. A little bit more of an angle on it for my the chamfer to start the thread. Okay, I use the tailstock to square up the die. Since I don't have enough swing on this lathe, I've got to turn the chuck. Using lots of cutting oil. I'll come back after I get it finished. I've got to tell you, that is one of the toughest threading jobs I've ever done. And if I had to do it again, I would single point it. I did something I've never done in 40 years of machining. I actually broke a die. It broke one of the teeth on the die. That's some tough material. Now what I have to do is mill a flat on this shoulder so that we can hold it to thread it in. I'm going to set up and go over to the milling machine. Okay, I've got it all set up in the mill, and what I'm going to do, I touched off already on it. What I'm going to do is take about 50 thousandths off of it. Then I'm going to go until it fits the 7/16 wrench. Almost there. A couple more thousandths will be perfect. Perfect. Okay, the next thing I have to do is drill and tap the hole in the bracket for the 3/8. I'm going to do that off camera and come back after I'm finished. Then once this is threaded in with Loctite and it's set, then I have to take and mill a flat on the shaft that will line up with a set screw or a retaining screw that's actually in the base of the string base. It's on the foot, the bracket that holds the foot on the string base, and that's really only is critical because if it's not in the correct orientation, the wheel won't be straight in line with the way that the base wants to roll. So once I get that all back together, we'll figure out where that flat goes. Here's the assembled wheel. Now all I have to do is mill a flat 90 degrees to the track of the wheel, because the set screw goes in from the side. So I'll take and set this up in the milling machine and level the wheel, and then go in and side cut it with a milling cutter to cut the flat. Okay, I've got it all set up. The wheel is level, and this is not the only thing that's critical about this is the orientation of it to the wheel. The depth, very often these are actually hand ground, so and that should do it. Flat is machined and it's ready to be installed. Well, if you've gotten this far in the video, please like it and subscribe to my channel. I'm listed under R. Stephen Lang. It's Shark River Machine, but my actual YouTube title is R. Stephen Lang. Please come back for more.